Hello and welcome to section 2.4. In this section we're going to talk about chain rule. The chain rule deals with composite functions, functions inside of functions. So we're used to these guys over here where we have just a standard function and we can take the derivative of it. We're even somewhat comfortable with multiplication of two functions and division of two functions. But then the chain rule is when we have functions inside of functions. So this x squared plus 1 is a function inside the square root function. The 6x is a function inside the sine of x, sine function. And the x squared here on the end is inside the tangent function. So when we go ahead and take the derivative of these, we're going to do it in terms of x every time, but it's going to take us one more step. And so there are two ways to kind of think of it. Like we can think of this as a composite function where we're taking the derivative of a function inside of another function. And so we take the derivative of the outside function, leaving the inside function alone, and then take the derivative of that inside function and multiply them together. Good way to look at it is think of it in terms of y. If u is my inner function, then I take the derivative of the outside, what's happening on the outside, and we multiply it by the derivative of the inside function. And so we can do a kind of a u substitution if you want, if that will help you. We can talk about that in class. So here's an example of it, and I'm just going to go through it without much explanation because we're going to have plenty of time to practice this. So if I want to take the derivative of f of x, then I would go ahead and take the derivative of the outside, which is this 3, and so that will give me 3 times 4x minus 1 squared. It's the derivative of the outside. And then what is the derivative of the inside function? Well, the inside function is this 4x minus 1, and so the derivative of that is 4. And so now the final answer for this ends up being 12 times 4x minus 1 squared. Now that's the velocity function. And if I had to do it, if I had to take the second derivative of this function, then I would do the same thing. The 12 is a constant multiple. It just stays as is. Take the derivative of the outside, which is 2, and then leave the inside alone. Reduce that outside power by 1. So there's a 1 there, but I'm not going to write it. And then multiply by the derivative of the inside, which then gives me something like, let's see, 8 and 12 would be 96 times 4x minus 1, and then I could distribute that if I wanted, and that would be our acceleration function when we have our velocity function up above and our position function at the very top. So I just thought I'd show you the second derivative on that, just to kind of hopefully get the chain rule figuring out. But we'll talk more about it in class. We'll have plenty of times to practice it. So then this leads us to the general power rule, and basically when we're taking the derivative of these chain rules, we take the power, move it out front, leave the inside alone, and then take the derivative of that inside. And that's really all of this, what these two things are talking about. It's just another way to talk about the chain rule in terms of the way the book might write them. So then how does it affect us when we're dealing with sine, cosine, and all of those things? Like you saw that function earlier, that was something like y equaled sine of 6x. Well, this 6x is my inside function, so I will take the derivative. When I do the derivative of this, I'll take the derivative of the outside, which would give me cosine of 6x. And then since 6x is my inside function, I would multiply that by 6 because that's the derivative of 6x, and that means that my final answer for my derivative is 6 cosine 6x. And so that would be the chain rule on a trig function. And so they all follow these rules, and you may notice that when I take the derivative, just like before, when I take the derivative of something that doesn't begin with c, I get positives, and anything that I take the derivative of that begins with c will get me a negative. And so, oops, and that's supposed to be squared here. That's not supposed to be a big 2. That's supposed to be a little 2. That's supposed to be cosecant squared. So sorry about that. And same thing with secant squared over here. Those are supposed to be powers, not just 2's. All right, so make sure you guys make note of that when you're looking at these. So those are squared. And so that's our chain rule, derivatives of chain rules, and we'll talk more about this stuff in class.